Are we live? Hooray! Let me alert the Twitter. I'll get this figured out one day. Found it. Some more unused variable warnings. What did I say last time? Not very good at this. On implementing some more compiler warnings. Okay. I have alerted my non-existent following. All right, so last time we worked on these unused parameter warnings, and I improved what we did a little bit, and so I thought I would walk through the diff. And let me make my face smaller for a little bit. Here we go. While we walk through this to see sort of where we landed last time, and then today I thought it'd be really fun to just get these warnings showing up in the LSP so that we get like a yellow or an orange underline for the warnings, because they're not currently showing up like the errors are. And I thought it'd be really a quick one. I only have maybe 45 minutes, really should be 30 tonight. So I thought that would be a nice way to spend the evening. So let's walk through what we did last time. So you can see here, we're now naming things with a leading underscore to indicate that we're not going to use them, and that squelches the warning we implemented. So that's nice and important. And so I'll skip over the rest of the changes to our K1 code, and we'll get straight into types. So I did end up removing the span, which is the source code location, from the type of function param. We spent a long time chasing the wrong bug because of this. So I got that removed, and we added it to the function itself where it lists its parameters. And so the rest of this diff, you'll see basically something that was a variable ID became a struct that has a variable ID in it, and a lot of just like small changes around that is most of the diff. This is one of those. So instead of right here, we have a variable ID iterating this thing, we actually now have this param struct, and we say param.variable ID. So that's the essence of that change kind of everywhere. We have it happening again here, nothing really crazy. This is in our LLVM codegen. One thing of note here is that we do need a span, and now I'm getting the span from my new record thing. So this is actually a more accurate source location for the LLVM debug info too, which is nice. That's a win. Our thing where we print how many warnings there were, fixing the color of the underline thingies that I call thingies. This is the struct we added. And then you add the rest of that change kind of plumbing through. We added non-errors. And okay, I went ahead. So all the new code we wrote is now in warn variable usage counts per variable ID. So it's called per span variable ID, which is kind of nice. And so this is for a closure. So if we go to our, if we go to simple, this friend here, he has an unused y, and we'll now be seeing that we get parameter y is never used, right? And so we weren't having that last time, and it's just because we weren't calling our new code for lambdas. So it's as simple as that. So my vision is whether it's a lambda, a function, or a block, or a block would have lets in it, anything that makes variables, when it's done, it should just kind of call, warn usage counts on all of the variables it made that the user could no longer possibly use if it's returned by now. So I moved some of these random comments out that were in the wrong file, and then it's simple. So that's it. So that's where we left off. And so what's next? Well, we could go take a look at the our LSP implementation and first try and get this thing underlining and get a diagnostic from the LSP for this. I thought that would be kind of fun. So let's try. Error to diagnostic. So here we've hard-coded some severity. And there is a warning. So we're gonna want, ooh, it's going crazy. Severity. Is this error? So what's interesting is I wanted to rename this from typer error to typer message or diagnostic or something, right? Last time. We can hold off on that for now to not bite off too much, but we will take in the full error because I want the level now. We want to match on the error.level, and then we'll fill these, and let's see if you know what I'm trying to do. Yeah. Is that even correct? Cool. Serverity message, and this is going to be error message clone. And what else is happening? Error.span. Span. Okay. Oh, no. No. It is. All right. Look good? I don't really want to allocate that. Is this how I do it? Do I do this? Const k1 stir. I can't have it be boxed, right, and have it be const. Like, oh, I just don't. I don't. I hate this. Let's do this. Let's do the program name or the module name or something. Ast. Oh. Dot name. And then we're at least cloning something with information in it. Maybe slightly better. Still terrible. Okay. DAA CAA-E. Parse error. Oh, okay, I see you. So this is one of those times where you wanna use your type. You love your little type. It's so neat, so nice and neat. And eventually maybe we could do a trait, but sometimes you just want the function to take the things that it needs so that it's more flexible to call. People don't have to construct your stupid object if they don't want. Okay. Oh, we own that. We own message now. Yeah. e.message. Sadly, e.level, e.span. Shoot. This is a parse error. Okay, parse error. Error level. Oh, because it could be lexing or parsing. I see. They are methods. And that's fair. All right. Gross. I hate everything about what's going on in this file, except that we already have all the information and are really just building up JSON. That's kind of nice. E-message clone. All right, all errors though. So all that did was refactor the thing a bit. So this is errors. I think we want to report them. Parse errors. All errors, sure. So module.errors, all errors, extend module.non-errors, map, the exact same line. It's important not to worry too much about how nice code like this looks too early. I know that I know how to make this like 2 words of typing, but I don't need to do that right now. It wouldn't accomplish anything. Okay. So there's a thing called build LSP, which actually will run when I K1 reload. Let me just make sure, convince myself. Yeah, okay. Let's watch it build. So this will do a release build of the LSP binary, which uses the rest of the compiler essentially as a dependency. I think I can make my face bigger again. Hello. Connect streaming software to start preview. Okay, it is working. All right, so that built. So let's try a reload. Oh my goodness. Oh, it took me right to the Y. Ready? I'm gonna refresh. Oh. Okay, ready? Oh, I see you. I see you. Thank you for coming to my TED Talk. How long have we been at this? 15 minutes. Let's take the W and then maybe we try. Oh, wait. Ah! All right, yeah, let's take this and ferry the non-errors to the LSP diagnostics. Okay, let's try and do lets, okay? My lets. Let x equal 4, let y equal 5, and that's our function. Sound good? So my thought on this, here's where this could get tricky. So we have a block, right? The function is implemented by saying I expect the block, but there's more blocks in this language. There's let y equals, and let's do this. Oh, a lexical block, let foo equal 12, and then, let's say we're just gonna do 12, so we're not gonna use foo. So when we get to the end of this function, we know that foo was unused, right? We also need to know that x and y were unused. And I think that I can do each block independently. So every time I reach a closing brace, I say reach a closing brace, we parsed a while ago, but when we finish doing a block, we'll say, and we don't have to recursively do this is important. We will say non-recursively, okay, what were all of your let statements? And count variable warning for each of them. So let's just try that and see how we go. So we have a function called eval block. And we get to the end and we know our statements. I'm going to iterate them before the add. So we can just do for statement in, and then statements is, it's an M list. And I like to call iter instead, because this as deref, as all this, like, it's just, I know what Rust's trying to do with the ergonomics and it does help, but the clarity, like with when you just put the and that the number of different things that can call. Whew. Not the biggest fan. I just like an iter method or function. Okay. Match self dot statements to get. So simply we only care about lets. And we'll just do one of these, and this could be an if let, but we're going to start out this way. We're going to say let v, we're going to do self dot warn variable usage counts, kind name, local variable, I always do that. Let statement dot variable ID, let statement dot span. Hopefully that's the left-hand side span and not the span of the entire thing. All right, what do we think? Let's wait for the reload. I'm on 40% chance it works, 60% chance it don't. Okay. It says I have. Oh, wow. We're just one-shotting them tonight, huh? and foo. Oh my goodness. And it shows both. Well, oh my goodness. Let's fix. Oh, I did this for debugging. Haha. Local variables never use type name. Oh, sure. But why isn't it? Where's my underline? Neovim. Neovim. Where's my underline? What is this? Well, I'm pretty happy. Yeah, we'll change it to an if-let, I guess. We'll go ahead and change it to an if-let. Oh, wait. Rust analyzer. Oh, thank you. Okay. Unused. Run the unused check on lets. Okay, well, so I hope this, yeah, this is the code we wrote last time, by the way, and this is where it landed. So there was a point where it was a big mess. It was looking up the type, it was doing another thing, it had a name, there was a print line in there, and it was a mess. And that was what I landed with. And I actually kind of got it working, had a to-do about taking the span off of the thing, but I wasn't quite ready to bite that off, right? And that's where last session ended. You know, woke up the next day, you know, with a bit of clarity. I wasn't really thinking about it, but having slept on it, you just come back and it's like, okay, yeah, we should move this. You know, had a bit more, I don't know, drive. So I was able to do the cleanup that I had put off, right? And then that simplified this code massively because now, you know, we only need the variable ID. Went to pull it out and then realized, okay, what does this actually depend on? You know, and it ends up being, you know, we just had 2 one-shot reuses, right? And it's, of course, very simple, but it speaks to the architecture of everything else that we have this notion of variable ID and that it's, you know, it's filling what it seems to be the right slot. Insofar as lets and function parameters and lambda parameters and even globals are all variables of a kind that they are all very different, but they have this commonality, and our variable and our variable ID system represent that and give us this great, this good foundation location with which to add this functionality in a way that I feel like really good about the complexity of. So yeah, I wanted to share that it got a lot nicer than when we worked on it last time. And that's I think the key, especially if you get something working, because once it works, you know that all the pieces are there and then you can just go to sleep. And then the next day, right, you can go in and you can mess with it because you know that all of the raw components to function are in there, and you can be a lot more like aggressive with it than if you had it half working. You could be like, I might need all of this, right? So I want to share that insight. Yeah, I'm tempted to do another one. I'm tempted to do globals, but how do you know, When do you do globals? You do it at the very end. And the thing about my globals is I need a way to declare them as like exported. We'd ignore the warning for exported globals for sure. Yeah. But because these also have a variable ID, I think that's going to be getting incremented. Yeah, because the variable's in scope even for the global. So it will have been getting implemented. Let's just do a test. So let's do fun add module. So at the end of each module, and then we'll just do a nice little for G in self typed globals iter v. Oh wow, I could actually just global. So my intent is not to keep it this way, but right. So the only thing I don't like about this is it takes mute self because report pushes to errors or non-errors. This is throwaway code. We'll do this. Is it that? I just thank you, Rust. Okay. I need just the vars and spans. What do you think? That's pretty clonable. All right. What are we at? Just under 30 minutes. All right, what did we get? Global S2 is never used. It's never used. How many warnings? 145. Now, I do make a lot of globals, yeah, here for tests. I could mark those exported. But it looks like it's working. This one, obviously, we wouldn't want the warning on. Yeah, for globals, it's less obvious, right? And also, like, this is for people to use, right? This is library. But it's neat that it works. Ah. Yep. That doesn't use T. Right, JSON doesn't use T? That's interesting. It's not quite right. Test meta. This writes any T you give it out to JSON using our type schema introspection thing and meta programming. So this meta block begins compile time execution, and at compile time we grab the ID of T, the type ID of T, and then we invoke this function which writes some code as text to a string builder, then we call build, and then the compiler will immediately compile that string as if it were written right here, which is cool. But it's telling me that T, okay, in the expanded code, T is used. Oh, but maybe it's not used like if it's unit, right? Call write. We call this on bool. Well, that would take T. Yeah, this is really interesting, because this expands to code that definitely like, where's the struct part? Name is T. So this expands to code that definitely uses T. So maybe, it's like, and it's the function param. So it's after, it's unused. T is unused in the generic pass when I don't run this block, but whenever T is not the type variable T, then it does get used. Okay. So for meta programs like this, we may want to relax it a bit. I see. Yep, and similarly here, the writer is never used when this never gets expanded. So because this isn't a template, I don't like only run this once I have a T. We also type check the generic function. It just happens to immediately do a meta block. So if I were to do like T plus T, like this gets type checked, right? And then it uses T. But the thing is, the only thing that happens is immediately a meta block. So, and the meta block doesn't actually run on that generic pass, because there'd be no point to reflecting on a type variable. So like write JSON will get compiled n+1 times, where n is how many times it gets called with a real type. And that +1 time is the generic one. And in that one, we don't run the meta block. And in that one, all the parameters are unused. That's okay. String interp, wait is not used. I'm just sort of debugging. Oh yeah. I guess we have to implement this without using our string interpolation, huh? Ooh. So this is a string that immediately opens an embedded expression, and the embedded expression immediately opens up a string which has the expression 10 plus 10 in it. Okay, but I'm pretty satisfied with the unused let warnings, and it's probably, of all the ones I've added, the best one, because for function parameters, there's clearly some edge cases where you kind of want to be able to opt out of the warning. For globals, definitely, there's some things to figure out if they're, public or exported, right? If you don't intend to use them, but for locals, you pretty much always want to use a local or have to give it a discarded name. So I think I'll probably just call it there and wind down for the night. Thank you so much for watching if you did.